Assalamualaikum warahmatullahi wabarakatuh. Very good morning for everybody. It's a great pleasure for me to be invited to this conference, the IC3 INA 2025, from data to knowledge, the convergence of open link data and AI. I'm very sorry that I couldn't join directly to the venue because I have also to attend different activity as well at the same time. Right now, I'm in Brisbane for International Data Week conference and also StatsCon conference in the same week. So again, I appreciate for the organizer to invite me to the conference. Hopefully that we can discuss later about the our research and also further activities. So I'm Setia Pramana from Polytechnic Statistika STIS, and right now it's of course an honor for me to discuss of one of our research, which title From Ports to Policy by Transforming Ship Tracking Big Data into Official Statistics. Today, I will take you to a journey from the oceans to a policymaker desk, showing how the AS data, when combined with modern analytical techniques, can produce faster, smarter, and also more meaningful insight for public policy. But in the first section of my presentation, I will briefly like overview what we have done so far, and then later we'll focus on the AS data. So next, as we live in the era of Society 5.0, next slide, yeah, we can see that the digital and physical worlds are fully connected. People expect more information, which is real time, relevant, also trustworthy. But national statistic offices were designed for the industrial era where survey and census took months, sometimes years to complete. So modernization is essential. This modernization includes multimode data collections, new data sources, which will discuss today, data orchestration, also co-production, where government, academia, and also all of you in this conference, and also the private sector collaborate to produce official statistics that meet today's demand for agility and also precision. However, next slide, you can see that the transformation comes with major challenges. First, complexity of big data, which actually massive and structures and also constantly changing. Second challenges is data quality and security. How we do how do we ensure accuracy and privacy in open systems? The third challenges is the infrastructure challenge, where we need a robust system to store, not only to store, but also to process petabytes of data. And the fourth challenges actually is related to the human factor, where we need statisticians, data scientists, other um, field experts who understand machine learning, also data scientists who understand statisticality. And although they are challenges, these challenges bring opportunity where we can have real-time analysis, machine learning for giving insight discovery, also automation to enhance efficiency. These are not just buzzwords, but they are now critical for evidence-based policy. Yeah. Next, to maintain trust in innovations, national statistic offices such as Indonesia and also other national statistic offices in the world have developed the statistical quality assurance framework, which ensures that every innovations where AI, artificial intelligence, big data, or automation passes through a quality gate. As you see that from the slide here, we have a so-called general statistical business process model, where the statistical business process start from specified needs, designing, building, collecting, processing, analyzing, also to evaluating. All this stage of GSBPM can be enhanced, can be boosted by putting AI and also other data science techniques for uh, speeding the statistical business process. Of course, this also include the quality assurance framework to make sure that the data that we produce meaningful and also impactful. In the right hand side, you see that These are the dimension of quality, data quality, which are related to relevancy, timeliness, accessibility, accuracy, coherency, also interpretability. This GSBPM, which actually previously used by maybe a manual approach, we can now put the AI or AI-powered application, such as in the BPS right now, such as chatbot for using AI for helping the process, also data collection instrument, and also data analytical software. You see that here, Fasi, Bungitung, those actually some of AI-powered application to enhance the business process in BPS statistics in Indonesia right now. These AI tools such as FASI is support data collection and also analysis, which actually can improve the statistic produced so we can meet this national international standards. Next, big data. Of course, as mentioned before, uh, the transformation of national statistics not only in the process itself but also in terms of data sources. Right now, big data or alternative data sources has not only for the complementariness for timeliness survey in BPS, but also as one of the sources for producing official statistics in several countries, the National Statistic Office, several countries, they have also used the several big data sources as their experimental statistic and also official statistics. In BPS Statistics Indonesia, these are several big data sources that currently being used as part of the statistic business process in BPS. The first is mobile processing data, which actually being used mostly for our populations, right? And then the second and third is remote sensing, using satellite imageries to estimate agricultural area and also geospatial data, which actually related to the information obtained by citizen where they put that in the geospatial data. And the one that we are going to focus for this for today, for this morning presentation is the shipping data, which actually S data, the automatic identification system used by ships, which focus on our maritime analytics. However, after this, I will present also briefly what we have done, what BPS have done, also our colleague and our team have done for MPD and also remote sensing data. Thanks. For example, for NPD. So let's just begin with this is one of our BPS success story where BPS Statistics in Asia, I think starting from 2015 at that time, we together with Ministry of Tourism, also supported by Bapenas and also other agencies in Indonesia and also the UN statistic divisions use MPD for the first time is to monitor foreign tourist arrival. This can be replaced or complementing traditional surveys. So right now, this is part of the official statistic for tourism statistic, for inbound statistic, outbound statistic, and also for domestic tourism as well. So the advantage of this it actually it provides near real-time updates. So it enables district level estimates, and of course, this significantly reduce the fieldwork cost, also non-response burdens. For example, here, yes, reducing workload and numerators, right? So because before we have to go to check to tourists, but now we just need to use the MPD to reduce the workload and the enumerators in the field. For example, next slide, we see that in May 2000 and in May this year, 2025, Indonesia recorded over 1.3 million foreign tourist arrivals. This is the highest for the year, right? So showing strong pandemic recovery in this year. And you look at this mostly using based on the uh, uh, mobile person data. MPD has transformed tourism statistics from survey-based system to more data driven, also more real time, almost real time statistics. And this mobile position data also now is undergoing research on using not only for tourism statistics, but also for other statistics such as migration statistic, population dynamics, and also other official statistic cases. But we're still working on the research on that. And then next one is actually next. Yes, the next case is related to the modernization of national statistics using satellite imageries. So right now, the current situation when we have data from the field, we use the what's so-called area sampling frame survey, which actually this one also done together with BPPT or BPPT, which actually like the previous BRIN, right? So our colleague also from BRIN as a part of this project, where this area sampling frame survey used for monitoring growth phase using smartphone, and then take a pictures, and then from that pictures they make sure they combine with information from satellite. And then this is done actually for every month at the end of the month, so thousands of our enumerators go to the field and take a picture and report this information. Of course, this actually takes time, of course, right? So this current situation using also what's so-called crop cutting survey to estimate the productivity based on the area sampling frame survey. And then by combining the two, we can have rice productions. But of course, now the need of statistical data is becoming bigger, and also we try to use advanced technology by using the Earth observation to support, so to enhance the official statistic, especially for rice productions. So we are now working on always almost 3 years how to use satellite data for remote sensing data to predict the paddy growth phase. By using satellite, we can hopefully reduce the cost of sending a numerator to the field. Also, will also the increase the coverage because some area cannot be accessed, for example, or dangerous. Also, reduce the cost of having enumerators on the field. So this is still on working progress right now, and then hopefully it can be done soon to be part of official statistics. And then now we focus on the AI's data. Let's just the ships and also seas. So I will briefly introduce what is AI's data. So AIS data, or automatic identification system, is a maritime tracking system mandated by the International Maritime Organizations. So actually, these AIs automatically broadcast a ship ID, position, speed, also voyage status for every seconds or every times. I think I trust that some of the presenters before or the participant of the conference have used or have analyzed the AI data before. Originally, AI's data was used for navigation safety to prevent collision between ships, right? But this AI's data, it's actually now can be used for other purposes, not only for navigation safety, but also as a gold mine for researchers and also statisticians. So because these AIs data give like a constant stream of signal, which can reflect global trade between countries, logistic movement, and also economic activity between a region, between countries in the real times. So AIs equipped with the broadcasting message in times and also every milliseconds. Next, and also next one is every AI equipped ship transmitted its signal at interval of ranging between seconds to minutes, right? Although this information actually, some actually not that directly 2 or 3 seconds, but actually there are some uh, more minutes, but this is due to some situations. Uh, this AI's data utilize or provide will provide around 27 message types. Again, uh, these types can be categorized as static data, dynamic, and also voice related informations. For static information, it will be related to the ship's call sign, for example, IMO number, and also related to dynamic information related to the vessel current speed, course, and also this information will transmitted every 8 minutes, every minutes. And also other type of data produced is related to voyage related informations, voyage related to the destination, ETA, and also the drought. The drought is the distance between how deep is the ship into the sea. And this actually the frequency is quite often, right? If you see that because we have thousands of ships, and also the information is also given or sent every second, every minute, the data is enormous. But not only numerous, but this also can you see that this is transparent, also can be used for official statistics. So all the data obtained, the S data can be obtained from several repository. The one that we are working right now, we are together with the UN Global Platform from UN Statistics Division, where we can get the data by ask them or submitting the project proposal to them. Of course, we can also get access from different uh, repositories such as the Norwegian Coastal Administration, or let's say Ministry of Transportation, Indonesia, and also commercial providers. Of course, next is this AI's data. It's huge, it's massive, but it comes with also massive challenges, right? Related to the accessibility of the data, we have challenge about the direct interceptions, yeah, so they can capture radio receiver, but it demands also considerably technical knowledge and also resources. So the challenge of data size because it's around like 1 gigabyte per month, for example, for a simple analysis, for example. So, for example, our team keep working on 1 billion records because we have to analyze ships that comes and goes from Indonesia, for example. This also the challenge. So these are common issues for AI's data because why I mention this, we always knows about big data have several characteristic, right? One of the characteristics related to the veracity, the quality of the data. That's why we have to, before analysis, we have to check the data quality, and the S data can suffer with the corrupt data, the coverage limitations, and also anomalies, also missing data. Of course, there are some ways to clean the data. For example, we can have several steps. For example, speed and distance filters, right? And also route-based check to detect outliers. And this can be used for using several machine learning algorithms. For example, for noise reduction, anomaly detection, and etc. We also handle around 10 gig per month, which actually require robust computing infrastructure and also scalable data pipelines. Next is about the opportunity of ICE. Let me check. Okay, yes. Despite this issue, of course, the challenges, GIS data offer exceptional analytical power, right? The massive availability, right? So massive availability and rich historical time series because it's available stretched into back to 2005, and this also can be used for until like few years ago. Also, we can have granular level, like really we can go into detail location of the ships, not only the area but also exact. But usually we can in more granular, more detail means that more yeah, the size also larger the size of the data, and this granularity can also give more insight on the economic activity at the micro level. And also it has the powerful and also timely insights because we can get the data of almost like real time daily, yeah? But then this can be used for general economic insights, which actually will provide ahead of traditional reports. And of course, the some of the informations actually unbiased because it's actually give exact locations and also give the comprehensive coverage. Uh, okay. AS data now has become the key experimental source for institutions such as Eurostat and also UNSOK, UK, also IMF, and it can give early detection for economic trends, helping policymakers to anticipate rather than react. Next is the slide. Next slides. Let me check. Okay. So this is one the first experimental that our first this our means that me and my team, right? My team first experimental experiment to apply as that. Of course, other researchers have done that we have done more or similar thing, but this actually what we have done is to monitor port activities in Indonesia. So we integrated AI signal with the IHS ship registry and also world port index to identify vessel entries, access, and also port stay durations. The challenge actually, usually we use the information from the Minister of Transportations or the ports authority, right? And then we try to compare this data, the number of port calls or the number of ships that goes into the port or when or goes outside the port. We try to compare that with the data, administrative data or registered data. And of course, some of the ports doesn't have the port authority. That's how we can use this AS data to compare and to check whether the what it actually the real port calls in the ports, right? To define, of course, the challenges is not only saying what is the port because AIS data doesn't give like exact doesn't give whether it's inside the port or not. It just give the location, the H3 location, the exact location, right? But we have to define which actually the official boundary of the ports. So that's why we use data from stationary marine broadcast methods and also combined with official port boundaries from Ministry of Tourism. And then we can use this for checking the vessel activity inside and outside the ports. Next is, let me check, next slides. Okay, this is actually, of course, we try to use different this is data sources from as data. We try to use station marine broadcast method and also manual as to check, and then it is recommended based on our approach that we use the uh, using some of the data based on the information of the official for some ports, but some ports actually doesn't have official. We can use like clustering methods for stating which actually the location of the ports. Next is the greenhouse gas emissions using as data. This also collaboration with the previous one, and also this now is collaboration with the UN such divisions, ADB, Central Development Bank, also World Bank. we compare the data what we have found here with the data from World Bank, and then we focus on this estimating greenhouse gas emissions. So we use the AS data and also ship technical specifications to calculate total emission within Indonesia exclusive economic zone for 2022. So we use the data of several ships that inside the Indonesians, and then we obtain that we observe that we calculate the total emissions is 38.9 kiloton of CO2 equivalent. So spatial emission we see if you look at the on the on the middle, right, the Indonesian map, you see the line, the red line actually that the shipping routes or the ship routes from some area, from example in the north, from China, from Japan, and then going to the south to the Australia. And if you look at the Malacca Strait, it's actually one of the most traffic, the highest traffic, where also they have the highest greenhouse gas emissions. Of course, we try to validate this not only based on the official number, but also using the Sentinel data for methane concentrations. Next is, oh, yes, this we also use the first step we try to use the gas emission, right, to predict, to estimate, to approximate the gas emission in Indonesia. But then also we try to use this to find emissions from Indonesian apparatus shift abroad, so from outside. So we try to fill gaps about the official greenhouse emission accounts, right, by trying to estimate, right, the how many ships from outside or how many Indonesian ships that actually provide the emissions within and also outside within Indonesia, but also to outside Indonesia. This actually needed for the national our national account. And next one is we try to use the AIS data to estimate on to nowcast maritime GDP, right? Using AIS indicators such as number of visits, gross tonnage, and also time in ports. We developed a time series model such as ARIMA and also ARIMA X, and also yes, and a long short term memory and also random forest for predicting nowcasting of maritime GDP. Uh, and then we observe that we can nowcast the Q1 of 2025 GDP for maritime transport, which actually 11.42 trillion rupiah. And then the mean of absolute percentage error of this approach is only small, is only 1.01%, which is actually quite good for predicting or nowcasting the maritime GDP. This showing that the alternative data can serve as an early economic barometer for policymakers. Next one is we try to domestic trades. You know, it's this is the challenge for us or for BPS, such as Indonesia, or for other NSOs to find or to study the trade between regions in Indonesia. It's also easy. It's quite easy to export or import outside the country because usually we have like export import system, right? But within region Indonesia is actually one of the hardest area to measure accurately, right? We try to check the changes in ship's droughts, how deep it sits in the water, to estimate a cargo loads and also unloads. This approach allow us to construct an origin and destination metric you see on the right-hand side of maritime trade between provinces in Indonesia. The results showing that picture of interprovincial trade flows between 2019 and also 2024, which actually it's sometimes maybe difficult to obtain using a survey, for example. This study opens the new possibilities for analyzing logistic efficiently, regional balance, and also supply chain dynamics. Next one is the mapping of fishing activities. Of course, if you look at from the AS data, it contains information about type of ship types, right? Cargo, bulk carrier, or a tanker, right? So we can have also fishing uh, ships, right? This is our fifth use case in this presentations, which apply AS data for fisheries. We filtered as data for fishing vessels, and then the first we have done two study. The first one is using DB scan, a simple DB scan classing algorithm to identify fishing zones based on vessel behavior. Which actually we what does it mean with vessel behavior? Slow movement, which acts under 1.5 knots, and also prolonged activity within 3 and 12 hours. So we expect that if the ship actually doing nothing or like in some area, not that quick, means that the ship is doing some fishing activities. So from 1.2 million raw records, we identify around 600 valid fishing activities, and these activities are concentrated mostly in the near of Aru Islands and also Maroke. If you see that just down on the Papua area, right? That's uh, Aru and also Maroke. This method helps authorities to detect high risk of what's so-called illegal, unreported, and also unregulated fishing. And also, of course, this hopefully can contribute to sustainable fisheries management, which actually part of the SDGs 14, goal number 14. The next, actually, our last example of the AI is used for fishing is to predict productive tuna fishing zones, right? This actually we developed a machine learning model to identify potential tuna fishing zones in the eastern Indonesia for a blue economy hub. And then we here integrated multi-sources data from AIS, VMS, and also environmental parameters like sea surface temperature, chlorophyll A, bathymetry, and also salinity. We we use the random forest model, and then it give like almost 80% of accuracy. And then we observe that the uh, the yeah, we found that only 2.4 of sea grids were truly productive for tuna fishing, highlighting area for sustainable exploitations. And then the dashboard actually available on that link that see that in the slides. That's those are actually the activities or our research team, our research that I have done so far. And then next, let me check the next slide. Yes, this all of our activities cannot be done by without any collaborations. Our collaborator, also institution from IMF, UNSD. Actually, we have also Ronald Jensen over there. We have to add Ronald Jensen, Marky Muryawan from AI's task team, and also from ADB, also World Bank, Cheryl, also from BPS, our colleague, also from the Ministry of Fisheries, from the Project of Catalonia, and also from University of Sultan Ageng Tirtayasa, from BRIN, Mr. Rezi, that actually we plan to we collaborating on the fishings, and also from our students from Polytechnic Statistika SDIS. And this again showing that doing the analysis, doing the research right now is multidisciplinary research and a collaboration within between university, academics, also government, and also international organizations. And again, next is I will just briefly showing about one of our now the flagship activities, right, about regional hub. As you know, we have in the world there are four regional hubs from UIA, Rwanda, Brazil, and Indonesia. Hopefully, with this conference, you can participate with our regional hub Indonesia, which actually focus on the uh, activities on research and development, and also capacity building for national and also regional strategic offices in the region of Asia and the Pacific. And then hopefully by having this UN regional hub, which actually the secretariat actually in BPS Statistik Indonesia, in Polytechnic Statistik STIS, Indonesia can be a catalyst for development of big data and data science for official statistics in Asia and the Pacific. We have done several activities that I have done so far. Like last month, we have done a workshop on APD by collaborating with the Indonesian Aid and also other institution in the regions. I think that's all my presentation today. Okay. Uh, yeah. So, yeah, I still have conclusions. Hopefully that you can still have time for me to conclude, right? The data revolution is no longer coming, it's here. And then all of us, the role is to ensure that it produces trusted, timely, and also impactful statistics. And then specifically, it already shown that it is shown that the AI's data can be used for not only for maritime transport information, but also for estimating emissions, monitoring trades, forecasting GDP, also managing marine resources. And of course, these still have some uh, we need some collaborations, also innovation for make sure that we can have from the data to the decision. And then, of course, we are looking forward for collaboration with all of the participants, speakers, distinguished speakers, and also the organizer from Green. And then again, thank you very much for your attention. And then to our partners and colleagues who made this work possible. And then this is my email. Please do contact me if you have any further questions, any remarks, also feedbacks related to our approach, which actually can be used for improving our research in BPS and also from STS Indonesia. And again, thank you very much for your attention, and I'm looking forward for any comments and also feedback from all of you. Thank you very much.